Hi guys, welcome to cycle 2 of AS Maths, and we're going to start off with a pure paper. So, question 1. Well, this question is best dealt with thinking about vectors. So we're going to express these 2 points, and we're going to think of them as vectors. So let's call this A and B. Now, we want the perpendicular bisector of the line that joins these 2 points. So what is the line that joins these 2 points? Well, that's just the line AB. And if you recall from previous papers, that is given by B minus A, because that's how you get from A to B. You go backwards down A and then forward to B. And that's equal to 8 minus 4. So this is the line that joins them, and you'll notice that you can get the gradient of this line, and that's just the change in y, delta y, over delta x. So that's going to be minus 4 over 8, which is minus a half. So we've got this line from A to B, and now we want the perpendicular bisector. So we know 2 things about the perpendicular bisector. Firstly, it's at right angles, so it's got the opposite gradient. And the other thing we know is that it's the midpoint of this line. So we want the midpoint of AB. I'm going to call that M. And so that's going to be equal to, well, if I want to get to M, I have to go to A first and then halfway up the line from A to B. So it's A plus 1/2 A to B. That'll get me there, right? If here's the origin, for example, this is not what the actual points are, but just for illustration, if I want to get to B, if I want to get to M, I go to A and then I go halfway up this line. So what is this? Well, if we work it out, we'll get 6 and 5. So that's the coordinates of the midpoint, if we, from the origin. Okay, so now we're going to look at the line that is perpendicular to AB. Well, the gradient, you should know this is a fact that if 2 lines are perpendicular, this implies that the gradient of one multiplied by the gradient of the other is minus 1. So the gradient here is going to be 2. So the line so far, the equation of the line looks like y is equal to 2x plus c. And then to get what c is, we plug in a point that's on the line. Well, we know a point. We know that it passes through the midpoint. So we plug that in. We get 5 is equal to 12 plus c. So c is equal to minus 7. And then we want the point where this line passes through the x-axis. Well, obviously the y coordinate of that point is going to be 0, because that's what x-intercept is. What is the x coordinate? Well, it'll be when y is equal to 0, and that gives us an x coordinate of 7/2. So the point at which it passes through the x-axis is 7/2, 0. Okay. Next question is one about expanding a polynomial. So you'll use the binomial formula from the formula booklet. And in this case, we're just expanding this one, right? Because the first one's already expanded. There's no problem with that. There's no exponent. So this guy, you see that if you look in the formula booklet, you can map that A, what they call A, is in our case x over 2. B is equal to minus 4 over x. And n is equal to 6. And they want the coefficient of x squared. So you have to just you could write out the whole expansion, but that would be a waste of your time in an exam. You just got to be a little bit clever and realize that you will get a coefficient of x squared whenever this guy is multiplying something that has an x squared here, and whenever this x squared is multiplying something that's just a number here. And those are the only terms that will give you, x squared. It'll be 1 times x times something times x squared, or x squared times something times 1. So we need to look at which terms will be proportional to x to the naught, which is 1, and those which will be proportional to x squared. So so if you look at the way you build this, an expansion of this thing will sort of look like a to the 6th plus a to the 5th b plus a to the 4th b squared, and so on. And you see that a and b have opposite sort of powers of x. So, for example, in the linear term, the place where they would cancel out would be the a cubed b cubed term, because then you would get x cubed on the top and x cubed on the bottom. So the a cubed b cubed term would give us our linear term, which then would be multiplied by this x squared and give us an x squared term. And so this is our linear term. And the one which is just in x squared in the expansion is the one where this a is sort of got twice the number of powers as b, because then you'll have like sorry, when this one is to the power 4 and b is to the power 2, then you're going to have x to the 4th on the top divided by x squared, which is x squared. So this is the x squared term. So we're going to have 1 times so we have 6 choose 3. That's this linear term. So it's the 1 coming out and multiplying 6 choose 3 times a cubed. And I'm dropping the x squareds because they don't matter for working out. We're just working out the coefficients here. Times minus 4 cubed plus this x squared is going to multiply 6 choose 2 times 1/2 to the 4th times minus 4 squared. And you can just stick this into your calculator and get the answer. Okay, question 3. So we're told that we have a reflex angle, and that means basically that it's greater than 180 degrees. Sorry, greater than 90 degrees, I think. And they were told the cosine of theta is equal to k. So we're told that k is between 0 and 1. So if we think of the graph, the graph for cosine, it looks like this, right? Where this is 360 degrees, this is 180, this is 90. And you see that if k is between 0 and 1, technically you'd think that the theta could be somewhere here, but we're told that it's a reflex angle. And here theta is between 0 and 90, which is no good. So when is, excuse me, when is cosine of theta next between 0 and 1? Well, it's in this region here. So we know that theta has to be between 270 and whatever that is. So now we want an expression for sine theta. So if we just crunch through our this identity in the formula booklet, we get that the sine of theta is equal to plus or minus the square root of 1 minus k squared. But now we need to know which one to take, the positive or the negative. Well, if we look at the graph for sine, we'll see that, so that's 180, oops, that's 180, that's 360. So the region that we're interested in is this one here. And so we'll want to take the negative square root. So if you put this in, you'll realize that you need you're actually only really interested in this negative region. So this is actually equal to minus the square root of 1 minus k squared. So just to clarify, I didn't sort of mention earlier, but the point is that even though this region here is allowed, it's an angle, right? So it's really only allowed between 0 and 360. So this is the region that theta can be. So it must be between 270 and 360. And therefore, this is the region of the sine function that we're interested in. So it's negative. Okay. So now they want tan of theta. And for this, you just use the fact that tan of theta is equal to sine theta over cosine theta. So that's equal to minus square root 1 minus k squared all over k. And that's all there is that you need to worry about. And now they want you to explain why sine of 2 theta is negative for these values of k. Well, there's a couple of ways to do this, but you know that theta has to be greater than 270 and less than 360, which implies that 2 theta must be greater than 540 and less than 720. And if you draw out the sine function, then you notice if that's 360, then 360, that's 720. This is 540. So the region that you're interested in is this one, and you see that it's always negative. Okay, question 4. So here we have a setup. We've got a sort of segment of a big circle and then this chord across it. And we're asked to find this constant p if the area of the triangle and the segment being this bit at the bottom, the sector is the whole thing, but the segment is the bit at the bottom, and if they're equal. So firstly, we know that the area of the sector, like the whole thing, is 1/2 r squared theta. And we're told, and we know that the area of a triangle is 1/2 base times height. Well, what's the base and height of this triangle? I'm going to drop a vertical line down here, the right angle there. And so that this angle, it bisects this angle, so this is now theta over 2. And we know that this thing is called r, so we know that this is r sine of theta over 2, and this is r cosine of theta over 2. So this thing is going to be equal to 1/2 times the base, which is 2 copies of r sine theta, so times 2 sine theta over 2, times height, which is r, oh, there's an r there, r cosine of theta over 2. So this is r squared sine theta over 2 cosine theta over 2. So we're told that the area of the segment, which is equal to the area of the sector minus the area of the triangle, and we're told that this is equal to the area of the triangle. So we can rearrange this, bring that triangle over here, and get it so that we have 2 times the area of the triangle is equal to the area of the sector, which is 1/2 r squared theta. So we have that sine theta over 2 cosine theta over 2 is equal to 1/4 theta, just plugging in that result we got before. And then we recognize from the formula booklet, and this is pretty much the only tricky part, is that the left-hand side is actually equal to 1/2 sine of theta. So, these thetas over 2, obviously we don't want them because here's just sine of theta, so we look for a solution to bring these into a sine of theta instead of sine theta over 2. And therefore you can solve that sine of theta is equal to 1/2 theta. And so theta is equal to 2 sine theta, so p is equal to 2. Okay. Question 2. Well, this is actually very straightforward. The perimeter of AXB, well, if you look at the diagram, it's just going to be 2 copies of this r sine theta over 2 plus the arc length, which you can find from formula booklet, is r theta. So we have that it's 2 copies of r sine of theta over 2 plus r theta, and then you just plug in r and theta. Okay, question 5. They want us to prove this identity, and these are the kind of things that you just sort of get in the habit of knowing how to do. You know which things make sense to plug in. So when you got a sum of fractions, the first thing you kind of want to do is pull them all together and see what comes out. So I'm going to pull these together into a single fraction, and I get 1 plus, I'm just going to use s and c for sine and cosine. 1 plus s minus c squared over c1 plus s. Oops. And then I notice that 1 minus c squared is just s squared. So that's s squared plus s over c1 plus s. I take an s out of the top, so it becomes s plus 1 over c s plus 1. These cancel, gives us s over c, which is equal to t. So you can see it doesn't take too long, but sometimes you can end up faffing around for ages, like trying different things, and getting lost and ending up with what you started with. So just practice, I guess. Okay, so now they want us to use this information to solve this equation. So we know that this thing here is tan of theta, and it is equal to minus 2. So we have that tan theta is equal to minus 2. And we're told that theta is between 0 and 360. So let's look at our tangent graph. The tangent graph goes up like this, and then comes back, and that's 180, not 360. It's always good to remember. Then it goes up like that, and then like that again, and that's 360. So there's a period of 180, not 360. Now, when is it equal to minus 2? Well, it's going to be equal to it somewhere here, and then somewhere again there. So there's going to be 2 solutions within this range, 2 values of theta, which will give us the tangent of minus 2. So that's this value of theta and this value of theta. And so you'll just, you can put that into calculator. That'll give you the first one. And then you recognize that, that this distance here, this value of theta, that's your theta 1, is equal to the distance between theta 2 and 180. So you just go 180 plus 180 plus theta 1. And that's all you have to do. So usually with these, they'll give you something that has more than one solution just to try and trick you. Okay, series. So we've got a geometric progression. What does that look like? Well, geometric looks like a, some initial value, plus a times r, plus ar squared, plus ar cubed. And you'll notice the pattern that the nth term, so this is the first term, second term, third term, fourth term. The nth term is equal to a times r times n minus 1. And in arithmetic progression, it looks like this: a plus k plus a plus 2k, and so on. And you notice the pattern is that the nth term is a plus n minus 1k. That's the nth term. So we're told that the first terms are the same. So, and then they're both equal to 8. So a is equal to 8. I've called them both a here. Technically, I should have called it b and then told you that a was equal to b, but whatever. They're the same anyway. And now we're told the second term of the geometric progression is equal to the 9th term of the arithmetic progression. So the second term of the geometric is AR, and that's equal to the 9th term of this. So that's going to be A plus 8, okay? So I just plug in the value for A, and I get that R is equal to 1 plus K. And now the last piece of information they give us is that the third term is equal to the 21st term. So I've got the third term being AR squared, and that's equal to the 21st term, which is A plus 20, okay? And if I plug in, I get that 8r squared is equal to 8 plus 20k. And I'm going to plug in for r squared here. And that's going to give me that 8 times 1 plus k squared plus 2k, squaring with r, is equal to 8 plus 20k. And so we have that 8k squared minus 4k, and the linear terms cancel, is equal to 0. So I take, I take a 4k out, and I divide by 4k. And I see that either k is equal to 0 or k is equal to a half. But k cannot be equal to 0, because in that case the arithmetic progression would just be the same, and it would never increase. And also the geometric progression would blow up, would not converge, because it would be the same thing added again and again, because you're multiplying by 1 plus 0, and so the thing would just be an infinite, like 8 plus 8 plus 8 plus 8 plus 8. So we know that k must equal to 1/2, and therefore r is equal to 3/2. Okay, I think this is just a repeated page. Sorry about that. And now the last little bit of that arithmetic progression is finding the fourth term of each progression. Well, this is easy. We know the geometric one is given by ar cubed. So it's 8 times 4 cubed. And the arithmetic one is given by a plus 3k. And we can easily solve for that. So, oh, sorry, this shouldn't be 4. Whoops, that's 3/2. And this is going to be 8 plus 3/2 as well. Okay, question 7. So here we have vectors given to us in this nice column notation. So they want us first to show that AB is perpendicular to BC. So whenever you see perpendicular, you know you have to use a scalar product, also known as the dot product. But they've told us that we have to do that anyway. So first we want to find the line AB and the line BC. So as we said before, AB is equal to B minus A, which we work it out, which gives -2, -1, 2. And BC, which is C minus B, is equal to 3, 2, 4. So now if we take the dot product between these two, remember that V dot W is V1 W1 plus V2 W2 plus, and so on, however many dimensions your vector is. So we just multiply them like component wise. So it's going to be -2 times 3, which is -6. -1 times 2, which is -2. 2 times 4, which is +8. And this is equal to 0. So this was AB dot BC is equal to 0. And that means that AB is perpendicular to BC. Okay. So now they're talking about the line from C to D. And if you look up here, this is D. And we see that AB is parallel to CD. So that means that CD must just be some scaling of AB. Anything that's parallel, if they're parallel, they're basically the same vector, just scaled by some amount, just stretched or shrunk by some amount. So let's first look at the vector. So we say that CD is equal to some number k times the vector AB. In fact, the vector BA, because if it was the vector from A to B, that's actually going in the opposite direction, so there would be a minus sign coming out. So it's equal to some vector k times 2, 1, -2, which is minus AB. And we're told that the magnitude of CD is equal to 12 units. Well, that's going to be k times the magnitude of 2, 1, -2, which is k times 4, plus 1 plus 4 to the 1/2, Pythagoras, which is equal to 3k. So you find that k must be equal to 4. So CD is equal to 8, 4, minus 8. And now the last piece is to recognize that CD is equal to D minus C, and therefore that D is equal to CD plus C, and that's going to be equal to 12, 9, minus 2. So just sort of going backwards on the stuff that we did before. Okay, question 8. So here we're given a second derivative of this curve, and essentially we have to integrate it. So the second derivative tells us something about the nature of various points, but it doesn't tell us where those points are. It's the first derivative that tells us where the stationary points are. So we're going to need to integrate this back to get the first derivative. So the thing is to recognize that d squared y dx squared is the same thing as d dx of dy dx. Makes sense, right? You're just differentiating the first derivative. And this is equal to 2x minus 1. So we use separation of variables, excuse me, and we get d dy dx is equal to 2x minus 1 dx. And I'm going to integrate this. And this thing, you know, you could just think of this as something called f, you know, and then you're integrating sort of integral df. Well, that's just equal to f plus c, right? So this is equal to dy dx, and we'll put the constant on all the constants on the right hand side. This is going to be equal to x squared minus x plus constant. Now we know that it has a minimum at 3 minus 10. So that means that at 3 minus 10, dy dx is 0. So we can plug that in to find the we can plug 3 in to find what c is. So we get that 3 squared minus 3 plus c is equal to 0, which gives us that c is equal to minus 6. So that means that our dy dx, so this all means that dy dx is equal to x squared minus x minus 6, which we can factorize. And we get x minus 3, x plus 2. So that means that we have, you know, max mins at x is equal to 3, as expected. That was the one that we were given. And x is equal to minus 2. So this is the one that must be the maximum point, because that 3 was the minimum point. And now we need y as a function of x, because we've only got dy dx so far. So I'm going to separate variables on this guy again and say that dy is equal to x squared minus x minus 6 dx. And I'm going to integrate this, which gives me that y is equal to 1/3 x cubed minus 1/2 x squared minus 6x plus c. And now I'm going to plug in a point that I know is on this curve. Well, 3 minus 10 is on the curve. So we can go minus 10 is equal to 1/3 3 cubed minus 1/2 3 squared minus 6 times 3 plus c. So that gives us c is equal to 7/2. So now we have the entire equation of the line. This becomes 7/2. And we can therefore solve, we just plug in minus 2 and we get the value for y. 65 on 6. So we had to integrate twice and recognize what separation of variables meant when we had a second derivative, and then just crunch through a lot of substitution. Okay, question 9. So this is integration again, but this time using the fact that integration is the same thing as taking the area under a curve. And they're introducing these square roots because like square roots are actually quite easy to integrate. They're just, I say easy, but they're pretty standard. And so you should get into the habit of what they mean. Don't be too like scared about it. So they want us to find dy dx first. So for this equation y. So I'm just going to do it up here. I'm going to say that dy dx, well, the first term is going to disappear, and this is going to be, so I'm going to express this actually as 8 minus 4 minus x to the 1/2, which I think is a bit clearer when it comes to differentiation. So it's going to be minus, and then a half is going to come out, and then this is going to be 4 minus x to the minus a half, and then from the inside chain rule, you're going to multiply this by minus 1. So this is equal to 1 on 2 square root 4 minus x. And now they want us to integrate y dx. Well, that's going to be the integral of 8 minus 4 minus x to the 1/2 dx. So the first term is obviously just 8x, no problem. The second term, you just have to think of what would have given you that term had you differentiated it. So we know that this thing would have started as 4 minus x to the 3/2. And then if I had started with that, 3/2 would have come down. So I have to multiply this by 2/3. And there would have been a minus here. But then this minus from the inside would have come out. So I need to cancel it with a plus. So this is like from a to b, if I gave it just some random limit, evaluated between a and b. And that's what we need for that question. So now they want the equation of the tangent to the curve at p. Well, what do we know about tangents? Well, we know that they have the same gradient as the curve at that point. So dy dx, which is the gradient of the curve, evaluated at p, is equal to, if we just plug it in, 4 minus 3, because that's the x value of that point. So p is 3, 7. And this is equal to half. So we know that the gradient of the tangent is equal to a half. So we have that y is equal to 1/2 x plus c. Now we need to find c. Well, we find that by plugging in a point, and we know that p is definitely a point on the line. So we plug in that 7 is equal to 3/2 plus c. So c is equal to 11/2. So our final answer for this is that y is equal to 1/2 x plus 11/2. So now they want us to work out the area of the shaded region. Well, that's just the area under the curve and then subtracting the area under the line. So this area is just equal to this area minus this area. So that's equal to the integral. So remember, this is about the fact that integration is like taking the area under a curve. The integral of y curve dx, and where we need to give limits, and we're only taking it between x is equal to 0 and x is equal to 3. We don't care about this little finicky bit up here. We just want this area. So the limits are between 0 and 3. And we're going to subtract the integral of y line dx between 0 and 3. Well, we already worked out y curve, the integral of y curve. So that's, I need to charge this pen. That's equal to 8x plus 2/3 4 minus x to the 3/2 evaluated between 0 and 3 minus, and then if we integrate that equation for y that we just found, we get 1/4 x squared plus 11/2 x evaluated between 0 and 3. And if you plug all this into your calculator, you will get that this is equal to 7 over 12. So that wasn't so hard. Four marks in the bag. You just have to be used to thinking of integration as taking the area under a curve. Okay, last question. So we're given these two functions and some like fancy mathematical notation. So all this means is that f is the name of a function, and what it does is that it maps x to 2x plus 3. So whatever x is, it gets mapped to 2x plus 3. And we're told that the domain of this is the real numbers. Same thing goes for g. G is the name of the function. What it does is it maps x to x squared plus 4x. And its domain is that x is the real numbers. So they want us to solve the equation f of x. So this is just equal to f of x. So you're just applying the formula twice. Well, that means that wherever that you take f of x, which is 2x minus 3, and then you plug it back in wherever you see x. So this will be 2 times 2x minus 3 minus 3, which is 4x minus 9, and we're told this is equal to 11. So straightforwardly, that means that x is equal to 5. Okay, now they want us to find the range of g. So I think the easiest way to do this is to think about the derivative. So what is dg dx? Well, this is equal to 2x plus 4. And this is equal to 0 at the minimum, right? So this means that this is at a minimum when x is equal to minus 2. And therefore, when g of x is equal to 4 minus 8, which is equal to minus 4. So the lowest g can be is, you see that g is a parabola. So it's going to have some lowest point. And because, you see as x goes up, g goes up. So it has to be a sort of smiley parabola. So it's going to have a lowest point and it's going to go up. So if we take the derivative, we find what the lowest point is, and that happens when x is minus 2, and therefore when g is minus 4. So g is always greater than or equal to minus 4. And that's the range. Okay, so now they want the set of values of x for which g of x is greater than 12. So remember, this is our g of x, and they want where it's greater than 12. So we're going to say that x squared plus 4x is greater than 12. So if we rearrange this, we can then factorize to x plus 6, x minus 2. And this is greater than 0. And remember that this is basically giving us the roots of the places where the parabola crosses the line y is equal to 12. So that's this point and this point. So we see that g of x can go be greater than 12 in this direction and in this direction. So that means that x, and sorry, this is minus 6 and this is plus 2. So x must be greater than minus 6 and less. Oops, wrong way around. X must be x must be greater than 2, or x must be less than minus 6. You can't write that in one phrase because it's not continuous. Okay. Find the values of the constant p for which the equation g f of x equals p has 2 equal roots. Well, that's just g of f of x, right? And if you refer to what that means, wherever you see x in the g, you plug in f. So that's going to be f squared plus 4f, which is 2x minus 3 squared plus 4 times 2x minus 3, which is equal to 4x squared minus 4x minus 3, and we're saying this is equal to p. So our equation, our quadratic formula is 4x squared minus 4x minus 3 plus p equals 0. So when does a quadratic have two equal roots? Well, it happens when the discriminant delta is equal to 0. So this is equal to b squared minus 4 times a times c. And if you work this all out, you get that p is equal to minus 4. Okay, so we're given another function now. And we're told that, well, it's actually, it looks the same as g, but the point is that it has a different domain. So it's only valid for when x is greater than or equal to k. It's not just valid over all the real numbers, but only when x is greater than or equal to k. So remember, this thing is a parabola. And oops, it's a parabola like so. So they tell us that h has an inverse. You got to know that this means that h is 1 to 1. So that means that for every value of x, there is a single value of y, and for every value of y, there's a single value of x. Now, that's not true in general for parabola, because if I told you that y was equal to 100, that could have come from an x is equal to 10 or an x is equal to minus 10. So you can't go backwards without ambiguity. So what we can do is we can restrict the function and say, oh, I'm only going to consider this half. And then this half is unique, right? Because x is equal to 10 would be valid in this half. X equals 10 isn't even in this half. So it's just, you would know exactly which one you would go back to. You would go to the positive one. So they want the smallest possible value of k. So let's look at where the minimum is, this minimum here. So dh dx, well, that's just 2x plus 4 equal to 0. Gives us that this thing is, so x has to be greater than minus 2. This is minus 2. Oops. And so we know that therefore k has to be greater than or equal to minus 2. So the thing is unique. It's 1 to 1. It has an inverse only when we're taking this upper half. And the reason I'm saying at the upper half is because x has to be greater than or equal to k. So I'm looking for some minimum above which things are fine. If it was saying that x had to be less than k, then they would be talking about the left-hand side. Okay, now they want to find us to find an expression for h inverse. So I'm going to call h y. So y is equal to x squared plus 4x. And the procedure here is always to rearrange for y and then switch the labels of x and y. So this initially looks a bit weird and hard to do, but the trick is to complete the square, because you want to extract the x out without mixing everything up. So we can see that this means that y is equal to x plus 2 all squared minus 4. And then we take the 4 over, and then we take the square root. We get x plus 2 is equal to plus or minus square root of y plus 4. So x is equal to minus 2 plus or minus square root of y plus 4. Now, which root do we take? Well, we see that it has to be the positive root, right? Because x can't be less than minus 2. So you can't be minus 2 minus something. It has to be minus 2 plus something. So the answer to take is the square root plus the square root minus 4. And now I'm going to switch the labels, and that just gives me that y, or rather h inverse of x, is equal to minus 2 plus the square root of x plus 4. And that's the procedure. And we are done. I hope that was helpful for everybody. Let me know if you have any questions on the boards, and